very interesting project taking scanning to BIM. Something that maybe you wouldn't know about him is he's also worked in the Arctic, and he can tell you more. He was stationed there.
Yeah, good evening. I'm Pat Suermann from the Air Force Academy, and I think I'm actually going to start with a video here, and I'll tell you a little bit more about me after we see the first couple minutes of my video here. I hope this one has audio, but if not, I'll just narrate. It starts about now, so.
This is a proud and unforgettable day for all of us who have been associated with our nation's newest service academy. With the formal acceptance and dedication of this magnificent chapel, the United States Air Force Academy, as originally planned and approved, is completed. I predict that this inspiring and original chapel will soon be a nationally and internationally known symbol of the United States Air Force and this Air Force Academy.
The Air Force Academy Cadet Chapel's distinctive structure is synonymous with the Academy itself. The chapel represents commitment to religious freedom, a founding principle of our country. Its chapels and rooms house precious religious artifacts and provide a place of worship and inspirational ceremony. Even with all the accolades, there are some systematic problems that have existed for years. The chapel has leaked since it was constructed, and over the years, caulking, recaulking, patching, and more recaulking have not solved the problem. These Band-Aid approaches were done to save money, but in the long run have only allowed the deterioration to progress to where it is now a major issue. So what is the problem? This very complicated structure contains 32 miles of joints, massive amounts of caulk, and a steel skeleton enclosed with aluminum cladding that expands and contracts in the extreme Colorado climate.
It doesn't expand that much. It still usually stays pretty much together. But so as I was saying, I'm Pat Suermann. My last assignment before teaching at the Air Force Academy was as a commander at Thule Air Base in Greenland in the Arctic Circle. So whenever I can get outside and go to a nice day, I'm very happy to do so. So I'm really happy to be here with you. But it's amazing how time flies. I mean, for some of you, maybe you saw the footage that we just saw there from 1963. And when I was living in Colorado for the first time in 1986, and you can play this video please as well. I'll just talk while this is going on. I was actually an altar server for a Catholic priest named Father Bruno. I was an altar server I was a middle schooler as Father Robert Bruno in 1987, Midnight Mass. They had Catholic Midnight Mass in the Protestant chapel just so they could house more people in there. And then when I got back to the academy after being in Greenland in 2012, I was now Lieutenant Colonel, and Chaplain Bruno is a full colonel, and he was nearing retirement, but his very last thing that he wanted to see done was to discuss how we could renovate this chapel for all the reasons that you just saw there. 32 miles of joints. It has really basically leaked since the day that it was first commissioned. And so for a variety of reasons, they want to try to undertake a very real attempt at not just historical preservation, but making this chapel the type of building that it was always meant to be. And so one of the things I was happy about shortly before coming out here for this presentation is that they've released or will release soon, a solicitation to do a $5 million design, just the design, for trying to figure out how to disassemble the chapel and reassemble it the correct way. Because when it was first built, we know in the construction area, things are value engineered out, which basically means we're trying to save money and cut scope. And they took out an extra membrane that would have been between the aluminum cladding of the exterior of the facility and the tetrahedrons, which make up the steel structure and the ribs of the chapel themselves. They took those out. So now the only thing in between the steel structure and the aluminum cladding are some gaskets and some rubber that has tried to be caulked. And the climate at the Air Force Academy is extremely harsh. So anything in the military worth doing is worth overdoing. And so working with some folks from Autodesk, I was talking to Pete Kelsey, who I don't know if he's here in the audience or not, and Kirk Fisher, who's the Air Force account rep. Pete had just come off of doing some early work on the USS Arizona, doing underwater laser scanning, drones, laser scanning, terrestrial based. And so I said, well, we want to do the same for the Air Force Academy. We know that we have this problem. We know there's a lot of areas that are hard to get to. If you look from the floor of the Protestant chapel to the ceiling, it's 99 feet. The spires are 150 feet tall. This is a difficult challenge and something that needs to be done. Also, recently I watched a Wreck-It Ralph with my kids, and I realized that this has started to become part of our American lexicon. That is the basis for the Wreck-It Ralph chapel, which is only shown for a quick second when Jane Lynch's character, I don't know what her character is in the movie, but she gets married in the military chapel there. But so we need to document the way this facility is, but then hopefully do this in preparation for what could be a $50 to $80 million renovation in the near future. So, quick background on the Academy. If you've never heard of the Air Force Academy, it's in Colorado Springs, Colorado. It's right on the Front Range. It comprises about 18,000 acres just north of Colorado Springs, and it was a site chosen in the 1950s by a team of people that even included Charles Lindbergh. So it is very historic and very storied location. Everything at the Air Force Academy is a big rectangle in the true mid-century modern style, and the only thing that is not a rectangle is the chapel. So it is very dramatic when you see the chapel after you see the rest of the Acropolis, which is what they call the mesa, that is the cadet area. The architect was Walter Netsch of Skidmore, Owings and Merrill, and it was built by Robert E. McKee out of New Mexico. So we set about doing exactly what Real is all about. We set about capturing it, we set about processing that and computing it, and then we set about creating things. And so the rest of my slides will go through what we did as we went along. The exciting part for me was that I primarily just enabled access to the facility, because after 9/11, when I was a cadet, I graduated from the Academy in '97, but when I was a cadet there, routinely we'd have people drive onto the terrazzo, we would have people walk into the dorms and just wander around, and we're like, oh, okay, I guess someone's lost again. But after 9/11, that was all definitely changed, and there's a reason why they call it the Big Blue Zoo. Everything is gated and fenced and very secure. So I essentially enabled access. But in only about a week, working with Mike Catanian, I don't know if he's in here, Tristan Randall from Autodesk, Pete Kelsey, and then some really highly skilled engineering assistants from Peterson Air Force Base, we did a ton of data capture on this facility. We did a Leica terrestrial-based scanner, we did a Faro 330 scanner, we had a DJI Phantom 2 with GoPro, do both stills and video. I don't have another video to show you the aerial flight, but it's on YouTube if you're interested. And we went about trying to document every single thing about this building so that we could then take all that data and inform and author a never before done Revit model in 2015 of the Air Force Academy Chapel. This is going to be the best and most thorough ever that the government has ever given someone who's about to undertake a design. And so that's, if nothing else, I'm very happy about that. So here are some historic images of the chapel being built, giving you the idea of the scale and sort of what is underneath there, and maybe why this very intricate sculpture is leaking so much, and just taking a look at all those 32 miles of joints. So this is the aerial footage. Here's the team, and so that's at no time do I ever want to try to take credit for any of the other products that you're going to see here, because a lot of the things that were done in the computing phase were all done by other people. But that's what I appreciated was that Pete Kelsey there, seen outside, very happy in the morning with Tristan on the GoPro heads-up display right there. It took a lot of approvals to get this approved. As some people asked me last night, they were saying, did you file a flight plan? Because I think maybe they thought, oh, well, I'm in the Air Force, so we're exempt from FAA rules. We filed an actual FAA flight plan to fly that little tiny drone around the chapel. And the thing we did not file, though, was we were not supposed to fly inside, but we did. We flew the drone inside. And the fact that I'm still in the military is a testament that we did not break anything. So I'm very happy about that. But then we really only did about a week's worth of effort. We did a bunch of scans. We had about 1,300 photos. Sum total, we had about 30 gigs, mostly the 23 gigs of scanning. But there was a team that was worldwide. So Nicole Shoemaker here in San Francisco led the team. David Shear also did the lighting analysis, and Stephanie Egger did a lot of the sustainability analysis and daylighting. And Carlos is in San Diego. Aaron is in Fort Worth, if I'm not mistaken. Joseph and Dennis are in the Boston office, the Waltham, Massachusetts office, and then Simon and Elizabeth are out of London. So this was an all-in effort by Autodesk to see if they could drink their own Kool-Aid, do the hard project, and then be able to help their customers when they came calling, as opposed to just saying, well, I'm sure, just figure it out on your own. So a lot of compliments go out to Autodesk for really putting a lot of time and effort into this. The interesting thing when I was there, all that stuff, all that data stream that we had, Recap was really kind of our heads-up display. It was our awareness vehicle for making sure that we could get all that 30 gigabytes of data of the chapel all into one spot and be able to stitch it all together. But then after that, Nicole and her team really went all out with energy analysis for Revit, lighting analysis, computational fluid dynamics with air analysis, and then robot structural analysis with the 30 meters per second, the 30 mile per hour winds that hit the chapel routinely from the west. So that was the other thing. I've heard a lot of sessions where people are saying, well, what's the best? Is it photogrammetry? Is it LiDAR? I like that this team said, well, we're going to use the right tool for the right job. And they used everything. We had the original specifications. We have the actual hand-drawn drawings from Walter Netsch and Skidmore, Owings & Merrill from the 50s. We have a more recent effort, including that 3D Studio Max model that was from Bobby Valentine at URS. And we had a recent investigation where they did some destructive and very thorough investigatory work inside the chapel. So they used all that, and they started coming up with the Revit file. And one of the interesting things that they found through the course of this was things that they were trying to use for energy analysis to bound things weren't working, because they were using structural portions, but they weren't bounding the rooms, and so they couldn't do any of the energy analysis. What they wound up using, Nicole has told me since, is that they wound up using floors for all the tetrahedrons for the 17 spires of the chapel, which is very interesting to me, but that is partly why we are in this predicament in the first place. The building is not really, it doesn't really have a roof of any kind. It's really just sort of like a bunch of pieces of something that we are hoping to pretend that it is a roof. And so you can see a variety of things here where they would sometimes overlay the laser scan and other times try to make masses from just elevation and plan views, and they use the right tool for the right job. This is the fruit of their labor in Revit. You can see the levels that they've created and how much detail they did on this. And I was floored by the fact that they did most of this before I came out and met with the team in October. So from June to October, they really did almost all of the outside structure especially, and then they did a lot more detailing on the inside and overall analysis. So a lot of these other slides are things that I don't know as much about. This is David Shear's work, but he went and dug through the specifications to get the actual luminance that comes through the dolls, which are all the individual little stained glass pieces that are angled on the Protestant chapel. very thorough. And you can see this is very realistic for something that where the sun rises in the east and would be in that view there, and then the sun always sets in the west, and the left side of the chapel is bright. This is some of the wind loads. I'm not entirely familiar with this, but one of the things I thought was interesting is that this is simulating up here on the top right 70 feet per second for wind, which I said, well, whatever you're imagining for the wind, it's realistic, because I've been on the terrazzo wind, and this is a cadet pastime. They have dollies, which are carts. They hold up sheets, and they call it terrazzo sailing, and they go flying across the large concrete terrazzo there. So it is extremely windy. So for a place where we're supposed to learn how to fly, they make sure we do something that's one of the most difficult places. The creating portion, we really only worked with Autodesk for a week there on site at the Academy, and then Nicole's team has done many things since then. But I've taken this as a mandate to try to bring in new things into the classroom. And all the things that you're seeing here are done by 2 of my independent study cadets, so I'm particularly proud of this part. Not all of these are Autodesk products, so I'm aware of that. So hopefully you can help inform me on other ways that maybe Autodesk would replace some of these. But we have since taken facility-sized laser scans, and how am I on time?
You're yellow.
Am I yellow? Oh, there it is. Okay, I didn't know what I was looking for there. It never changed for most of the time, so okay. But I'll be done very soon. We took facility-sized laser scans, and we've extracted some of that information after you processed it in Recap, or with the Leica scanner, we got some of it out in Cyclone, brought it into Recap. Then we've extracted it with Geomagic from 3D Systems. They've graciously given us a free tool for that. Then we worked with the mechanical engineering department to use their MakerBot printers, because they don't have any other printers other than that. So we're looking forward to maybe more large-scale printers there. But we have actually printed up things not as nice as the Rembrandt, but the back relief of the Catholic chapel is a very large mosaic with added sort of flat relief statues on there, and that is the representative of that up there on the top. We've also scanned, that's Danielle Tabb. She's a hammer thrower on the track team, and I definitely don't mess with her because she could beat me up, but she is, we've done laser scan of the Holiday Athletic Center, which was the first BIM-based design facility that we had at the Air Force Academy, and we've been able to compare the scan with that and found many differences, so that was interesting. And then the very last thing I was going to say on there was we extracted the 9/11 memorial out of the Cadet Chapel scan, and we were able to print up the 9/11 memorial in a very low resolution 3D print. But so these are other things that the Autodesk team has been using, and they've said that now they sort of use the chapel as their test case. If they have a new software online, they say, well, let's try it on the chapel and see if we can do it on that crazy facility. And if we can do it there, then we can do it anywhere. Let's see here. Can you play that one? Do I have time for this one too? I'll just end it on this one here. And this is from Doug Eberhardt. He took publicly available information and then also added that we had high level fidelity LiDAR scan of the cadet area, and this was just doing scans that were relatively close to the chapel, but we got nearly the entire cadet area from Harmon Hall to to Vandy to Saigon. But that was a fly-through that we have now, where we can give anybody hyper reality of the chapel. So thank you very much. Appreciate it.